Hey everyone, welcome back for another deep dive. And today we're getting into something that's super fascinating, especially for all you philosophy fans out there. It's called relational quantum mechanics, or RQM. And buckle up, because this one's going to really stretch those brain muscles. Because RQM says that instead of like a fixed reality out there with all these set properties, the world might actually be all about relationships and how things interact with each other.
Yeah, it's a pretty radical way to look at quantum mechanics. Instead of putting wave functions at the center, RQM focuses on those moments when systems interact.
It's like those physics demos with billiard balls, right?
Exactly. Like when two billiard balls smack into each other, that's an interaction. And in RQM, it's during these interactions that things like position or momentum actually get specific values.
Okay, so that's where the Stanford Encyclopedia of Philosophy comes in.
Yeah.
We're going to be leaning on their entry on RQM today. And one of the things they highlight is how RQM kind of democratizes the whole observer thing. It's not just about scientists in a lab, right?
Yeah. Totally. Any physical system can be the observer in RQM. Like if a photon just happens to bounce off an atom in the atmosphere, that counts as an interaction and observation in the RQM sense.
So it's not about some conscious being looking at the universe. It's about systems affecting each other.
Exactly.
So we've got systems interacting and variables getting values during those interactions. But here's where it gets really interesting for a philosopher. RQM says these values are relative. They only exist within that specific interaction.
It's like how we already accept that velocity is relative in classical physics. Like a car's speed only matters compared to something else. Like the road RQM takes that idea and applies it way more broadly.
Mm.
It says that all physical variables are relational, position, momentum, spin. None of them have values on their own. They only come about through interactions.
Okay, so no absolute blueprint of the universe.
Yeah.
That's a huge shift. And as a philosopher, I bet you're already thinking about what this means for objectivity and like reality itself. If there's no absolute blueprint, what kind of world are we even in?
That's the cool thing about RQM. It forces us to confront those really big questions. It challenges that classic view of an objective reality with properties that already exist.
And what about the wave function? I mean, that's been the star of quantum mechanics for a while now. Does RQM just throw it out?
Not completely. It sees the wave function as a tool, but just a tool, a way to calculate probabilities, not a literal picture of reality, like the Hamilton-Jacobi functional in classical mechanics.
Yeah.
It's useful, but we don't think of it as a real physical thing.
So RQM kind of demystifies the wave function. But
Well,
what about those classic quantum paradoxes, like Schrodinger's cat, the one where the cat's supposedly both dead and alive until someone checks on it? Does RQM rescue the cat?
Well, RQM would say there's no need for a rescue. The paradox comes from thinking the cat has some absolute state of being dead or alive before we observe it. RQM says, hold on, the cat's state is always relative to the observer.
So the cat is either dead or alive, but we don't know which until we or some other system interacts with it. No more zombie cats.
Exactly. And remember, a real cat is super complex. There's constant interaction happening inside it and with the environment. That's decoherence. And it makes it practically impossible to see those weird quantum superpositions in big systems. So thankfully, zombie cats stay in the thought experiment zone.
Okay, so no zombie cat crisis. But you mentioned something earlier called sparse event ontology. Now that sounds straight out of philosophy class, which is perfect for our listener. Can you unpack that a bit?
Picture this. The world isn't a smooth, continuous movie. It's like a series of flashes interactions. Only in these flashes do variables actually get definite values. It's like the universe is a strobe light, not a smooth film. Between the flashes, things are in a state of possibility without set properties.
So instead of this constant flow, RQM says it's more like a cosmic dice roll where the dice only land when systems interact.
That's a great way to put it. It shows how RQM challenges our usual view of reality. It's less like a flowing river, more like a series of snapshots where reality comes into focus with each interaction.
Whoa, that's a seriously different way to think about things, and I think it's the perfect spot to take a break before we dive even deeper into this RQM rabbit hole. We'll be back in a flash.
All right, so we're back, and we were starting to see how big the implications of RQM might be for how we understand reality. I bet as a philosopher, you're wrestling with some pretty huge questions right now.
For sure. Like, does RQM just chuck the whole idea of realism out the window? If everything's defined by these interactions and they're all relative, is there even a world out there separate from what we see? It kind of sounds like we're heading towards solipsism.
That's a totally understandable concern, but RQM doesn't actually deny that there's a world outside our minds. It's still realist in the sense that it acknowledges a reality that exists whether we're perceiving it or not. What it questions is a specific kind of realism, the kind that says the world has these fixed properties that exist no matter what.
So it's not saying it's all in your head. It's more like what's out there is way more intertwined and dynamic than we thought.
That's it. RQM pushes us towards a kind of weaker realism, a realism that's all about relationships and interconnectedness, not fixed absolute properties.
I see. Even in classical physics, we've had to accept that some things are relative. Like velocity RQM just takes that idea and goes all in applying it to the very foundation of reality.
And it's worth pointing out this move towards relationality isn't brand new. It's been a recurring theme in physics. From Galileo and Newton to Einstein and beyond, our understanding of the universe has consistently moved towards seeing how interconnected everything is.
So RQM is part of this larger trend in science and philosophy. It's not just some random idea that popped up. But okay, if everything's relational, how do we know we're not all just stuck in our own bubbles of subjective reality? How do we know we're experiencing the same world?
Yeah.
That's what trips me up.
That's where intersubjectivity comes in for RQM. It's the idea that even though we each have our own perspectives, we can still come to a shared understanding of reality through how we interact.
Yeah.
Think about it. If two people look at a tree, they'll see it from slightly different angles, different lighting, even with different feelings about it, but they can still agree on basic facts about the tree.
Like, yep, there's a tree and it's tall and green, that kind of thing.
Yeah. Our observations are consistent not because we're forcing our own views onto the tree, but because there's something real and independent that we're both interacting with. RQM takes this a step further and bases this intersubjectivity on the very structure of quantum mechanics.
How so?
Remember, RQM says that quantum mechanics is fundamentally about correlations between systems. When we interact with something like that tree, we're not just passively watching it. We're creating a correlation and entanglement between our state and the state of the tree. That's how a shared reality emerges.
So it's not just that I see the tree as green,
Hmm.
it's that my state becomes entangled with the tree's greenness.
Yeah.
And that's what allows us to share the experience and knowledge of it.
Exactly. It's almost like the universe is weaving a web of connections between observers through these quantum correlations. Intersubjectivity isn't just some philosophical add-on to RQM. It's built into the very core of how RQM understands reality.
That's wild.
Yeah.
But this has to have some implications for science itself, right? Science is all about finding objective truths about the world. If everything's relational, how can we be sure we're not just chasing shadows stuck in our limited perspectives?
That's a great point, and it gets to the heart of some ongoing debates within RQM. Some physicists and philosophers say that the interpretation needs what they call a cross-perspective link to make sure different observers can actually compare their observations.
So, a way to guarantee we're all talking about the same things,
Oh.
even though our perspectives are limited and relational.
Right. This cross-perspective link would be like a bridge between observers, a common reference point to make sure their observations can be connected in a consistent way. But there's still debate about exactly how this link would work and if it's even necessary.
So there's healthy debate about how to square RQM's emphasis on perspective with the need for scientific objectivity.
Absolutely. It's a debate that touches on some really deep philosophical issues about what knowledge is, how we can be objective, and the role of the observer. But it also shows that RQM is a living, evolving interpretation. It's still being explored and refined.
Before we move on, can we loop back to sparse event ontology and really break down what it means for time? I'm still wrapping my head around reality as a series of flashes instead of a continuous flow.
It's definitely mind-bending, but it makes sense if you follow RQM's main ideas. If the world is a network of interactions and things only have definite properties during those interactions, then reality itself becomes discontinuous, kind of like it's flickering. It's like the universe is always in this state of becoming, with each interaction bringing a new set of actualities into existence.
So things don't just disappear between interactions. It's more like they exist in this blurry state of potential without fixed properties till they interact with something else, then bam, they snap into focus. It's like those old flip books where static images create the illusion of motion.
That's a great analogy. And it brings up a question that's central to RQM and its implications for time. If reality is fundamentally discrete, does that mean time is discrete too?
Whoa, are we talking about time moving in tiny quantized steps?
Yeah.
Like a cosmic clock ticking?
It's something some physicists and philosophers are seriously considering. Some interpretations of RQM do point towards a discrete picture of time where change happens in these quantized jumps. But there are others who say we can keep a continuous view of time and still explain the discreteness of quantum events.
So the nature of time in RQM is still a mystery, a philosophical puzzle waiting to be solved.
For sure.
Yeah.
And that's one of the reasons RQM keeps fascinating physicists and philosophers. It pushes us to confront the limits of what we know and to explore new ways of thinking about the universe and our place in it. It really shakes up those traditional philosophical categories of being and becoming.
All right, so we've explored the relational nature of reality, wrestled with objectivity and intersubjectivity, and even pondered the very nature of time. I think our philosopher friend is ready for the ultimate question. What does all this mean for how we understand the self?
That's the million-dollar question, and RQM kind of forces us to think about it. If the material world, even time itself, might be fundamentally relational and interconnected, can the self escape this web of interconnectedness?
Let's tackle that head on when we come back for our final segment of this deep dive. All right, so we're back and ready to tackle the big one, the self. If reality is this web of relationships like RQM suggests, what does that mean for how we think about our own identity?
This is where RQM gets super interesting for a philosopher. It makes us rethink some really deep assumptions about who we are.
Yeah, we've been talking about how objects and properties come about through interactions, but what about the subject, the one doing the observing? Are we also just nodes in this giant interconnected network?
RQM doesn't give us a direct answer, but it definitely makes us reconsider those traditional ideas of a fixed, isolated self.
So instead of static I, we're talking about a self that's always changing, always evolving, shaped by all the relationships we're part of.
That's one way to look at it. And it fits in with some philosophical ideas like process philosophy, which emphasizes how interconnected and ever changing everything is, including the self.
So instead of being some independent entity separate from the world, the self might be more like a process, a flow of experiences and interactions.
Exactly. And that actually echoes the idea of no self or anatta in some Buddhist philosophies, which challenge the idea of a permanent, unchanging soul.
That's a really cool connection.
Mhm.
So RQM might not have all the answers about the self, but it
Yeah.
definitely throws a wrench into that classic Cartesian view of a mind separate from matter.
It does, and it suggests that to understand the self, we need to understand the whole network of relationships that make it up our interactions with the world, with other people, even with our own thoughts and feelings.
So maybe instead of asking, what is the self, we should be asking, what are the processes that create the experience of self?
That's a great way to put it. It shifts the focus from trying to define this static thing to exploring the dynamic processes that give rise to the feeling of self.
This has some pretty big implications.
Yeah.
It makes you wonder if our sense of being an individual is just kind of a useful illusion, a way to navigate a world that's ultimately interconnected.
Yeah, that's a deep question, and I think it's one that RQM leaves open for us to explore. It gives us this new framework for thinking about the self, but it doesn't force a specific answer on us.
Well, I think we've taken our philosopher friend on quite a trip through our QM today. We've gone from the super small to the super big,
Yeah.
from the nature of reality to the nature of the
We
self.
challenged some fundamental assumptions and hopefully opened up some new ways of thinking about the universe and our place in it.
So let's do a quick recap of the key takeaways of RQM for our listener who's been with us on this whole deep dive.
First, RQM shifts the focus from wave functions to interactions as the basic building blocks of reality. It's in those interactions that physical variables get their values, and those values are always relative to the observer or the system that's interacting.
Second, RQM challenges our traditional ideas about realism. It suggests that the world isn't made up of objects with fixed built-in properties, but rather it's this dynamic web of relationships where properties come about through interactions.
And lastly, RQM makes us rethink the nature of the self. If everything is relational, then maybe the self isn't this fixed entity, but a process that's always being shaped by how we interact with the world and each other.
RQM is a radical interpretation, but it's coherent, and it makes sense. It avoids some of the paradoxes and baggage of other interpretations while giving us a fresh perspective on some really old philosophical questions.
And for a philosopher, I think it's a goldmine. It gives a whole new set of tools and concepts for thinking about some of the most fundamental questions about existence.
So to our philosopher friend out there, if you're looking for a way to bridge the gap between physics and metaphysics, RQM is definitely worth checking out. It's a journey into the heart of reality itself, where the lines between observer and observed, subject and object start to blur.
And who knows, maybe by wrestling with the weirdness of quantum mechanics, we can even come to a deeper understanding of ourselves and our place in this interconnected universe.
It's a journey worth taking. Thanks for joining us on this deep dive into relational quantum mechanics. Until next time, keep asking those big questions and keep diving deep.